Hi everybody and welcome. This is Hassan Al-Banawi speaking. And now we can see our function, which is x to the power of 2 plus 1 equals 0. And we can see the two dimensions here. It's the x and z. And x should be a real number and z will be the output. And it's also a real number. And from the figure here, we can see that we don't have any intersection between our function and the x-axis, which means that we don't have any real solution. As a polynomial, we should have two solutions because this is a second degree polynomial, and they are based on this function. They are not real because we don't have here an intersection between this function and our line and the x-axis. Okay, so I will start rotating this function here, as you can see, and as it's rotating we will see that it doesn't have any existence in the y direction. So y will represent the imaginary part of the input, and we can see starting from now that if we have a value for this imaginary part, the function will start to build up around the z-axis, as you can see here. And this will be the 3D representation of our function. This function that we see here, this is only the real part of the output, and there should be another graph representing the imaginary part, because we have two dimensions for the input, one for the real part and one for the imaginary part, and we should have two dimensions also for the output, one for the real part and one for the imaginary part. But as our world is only 3D, so we can't have four dimensions on this graph, only three dimensions. So this graph here is representing the real part of the output on the z-axis. Okay, to get a solution for this function, both the real part and the imaginary part of the output should equal 0. From the other curve related to the imaginary part of the output, we will see that the value of the imaginary part will equal 0 at 0 input in the real part, or 0 input for the imaginary part. This can be represented by these two curves here, the red one and the orange one. So these lines here representing a 0 for the imaginary part. So starting from now, we know that our solution should be 2 points on these two lines. Okay, so the other condition to get a 0 for the function is to have 0 for the real part of the output also. So we will see where this function intersect with the 0 of the z-axis, and this can be seen from the green lines here, and I guess they should be a little bit seen now. So this green lines here representing 0 value of the z or the real part of the output, and we can see here that the intersection between the orange and the green line, these 2 points have 0 for the real part and 0 for the imaginary part, which means that they can be or they are the solution or the roots of this function. And these 2 points are 0 on the x-axis and 1 on the y-axis, which represents the imaginary part. So this means 0 plus 1i, and the other point is 0 plus minus 1i. And these are the solutions for our function. Thank you.